Today we will be learning about a class of machine learning tasks, what we call regression problems, and particularly a specific model, what we call linear regression. The plan looks like this. We are familiar with the straight line equation, so we will take that straight line and connect to the linear regression model. Okay. In the second part, we will learn a very popular machine learning algorithm, what we call gradient descent, which works for simple models like linear regression and is equally applicable for very complex models like neural networks. Okay, so we need to stick to this lecture so we understand certain concepts which you will require training many machine learning algorithms. Okay, so the second part also includes some coding which you will need to really learn from the scratch to craft better models. Okay, so let's start. So we have talked about our first machine learning model, which is a k-nearest neighborhood model. And when we were discussing that particular topic, we introduced you to this problem that given some red triangles and blue squares as your data, you have to use those data to classify a new incoming data point, okay, which is a green circle in this case. Okay, so if you got the general idea of k-nearest neighborhood models, then you can quickly classify it into one of these two categories by estimating the distance between the given data point and all other available data points. Okay, so this is a purely distance-based model, and we mentioned that this is a non-parametric model and of course supervised. We didn't explain this part. I think by learning the content of this lecture, you will be able to figure out what we mean by non-parametric models. Okay. If you are clear that this is a classification task, given a new point, we needed to classify it into either as a triangle or a square. Okay. What are some other examples of classification tasks? For example, email spam filter, face recognition, cancer detection, sentiment classification. Okay, so one thing is common in all these problems, that the y or target variable is actually within a predefined set of categories. Okay, so this one is two shapes, and then spam filter is yes spam or not spam. Then sentiment classification is happy, sad, or confused. Okay, so in all these cases your y variable has a predefined set of values. Okay, so this is why we call it classification problem. Okay, the other class of problems, what we call regression problems, where the y is actually a real valued variable. Okay, some examples are insurance cost, house price, okay, sales forecasting, energy consumption predictions. Okay, so these are regression problems. And how do you differentiate between classification and regression? In the classification, we have the y in a predefined set of values, and then for regression the domain is open. Okay, so it can take any value. Okay, so today we'll be talking about a very specific simple regression task. Given the information of a person's height, you have to predict his or her weight. So this is a regression task, and you quickly figure this out that the height and weight, they have a correlation. Okay, so a small kid will have less height and then their weight will be also less compared to adults, right? Okay, so we are given two data points. and we want to use our KNN model to do the prediction. So given this new data point x prime, what we have to do, so we estimate the distance between this dotted arrow and all the available data points, okay? And we quickly figured this out, that this new x prime is closer to x2 y2, okay, because this distance is way less than this distance, okay? And if we use one nearest neighborhood model, then we'll just propagate the level, right? If you have x prime as your height, then your weight will be this y2, okay? So very simple idea. Now the question is, are you aware of a better model than the KNN model? And the answer is yes, okay? Because we all have learned straight line equation and we can use this to do the same task. So let's do a little bit review on linear equation. We are using the same two data points, okay? And this is the straight line. And we all know that straight line equation is y equal to beta 0 plus beta 1 x, okay? So this beta 0, we are calling it as the intercept, okay? So where does this line actually intersects with the y? And then this beta 1 is actually the ratio of delta y and delta x, okay? So this is what we call slope, okay? If you recall the straight line equation, and as we are given these two data points, delta y is y2 minus y1 and delta x is x2 minus x1, because we have these two data points, so we can estimate beta 1, right? So when you have beta 1, you can take any of the data points, you plug their value y and then the beta 1 and corresponding x, okay? That will give you the value beta 0, okay? So again, if you know beta 1, from any data point, any of these 2 points, you can estimate beta 0 by plugging the y and x values, right? Once you have those parameter values, then you can do a prediction for a new data point, okay? And how do you do that? So for this new x prime, you just plug in the values here, okay? So your x prime, and you already know beta 0 and beta 1, and then you get y, okay? The y will be here, okay? So you have used a straight line to do the prediction, and it is your regression model, right? Now the question is, which model is better, okay? So let's compare. The phenomena is already known that the x height and y weight, they have a linear relationship, okay? So if x increases, y should increase, okay? So as you can see from this figure, okay? So if your height is higher, you expect that your weight will be higher, okay? Generally, we may have an exception, but the KNN model told us that this guy is actually with this same weight as this guy, even he or she has higher height, okay, which is not looks to be fair, okay? But the straight line was able to correct that, right? Okay. Again, we may have exceptions, but we are trying to learn the general relationship, okay? In summary, we have learned our second machine learning model, what we call a linear line model, which we already learned in our high school math. I just tried to clarify through some examples, okay? So now we have KNN model and linear line model, and we have looked at that for this particular setup, the linear line is doing better than the KNN model, where here we learned about a new model which we call a parametric model, because once you have figured out beta 0 and beta 1 values, then you can throw these two data points, okay? But for KNN model, you will always need to keep these data points in your memory, okay? So in our coming classes, we'll be discussing more about the topic, but KNN model is a non-parametric model where line is a parametric model, okay? So that was the topic of discussion of this part. In the next part, we will use our line to craft our linear regression model. Okay. If you have any questions, feel free to ask me at any time. Okay. Thank you.